Okay, this is the final lesson for Unit 2, and it's looking at the intersection of three planes. So what's our goal today? Can use previous skills, and we're going to have to use, in this case, we're talking about matrices, and we're talking about some substitution and elimination. So you can use previous skills to determine the solution for three planes, and then use words and diagrams to explain your answer. There are quite a few different scenarios with the planes, so I've got some of these already drawn up, so you'll need to pause the video, get the sketching done, and then make sure you do listen to what I say about each of the possible scenarios here. So, the first group here. We have the three cases that I'm looking at. In this case, I am looking at sort of a grouping, and it deals with the normals being all the same. So I have all three planes are coplanar, or they're the same plane. I have two planes coplanar and one parallel, and I have all three planes being parallel. So in this case, all the equations are going to be in the standard form for you because there's enough going on you don't have to worry about converting. With these three cases, because all the normals are in the same direction, so all the normals are perpendicular to the planes, it allows us to create a comparison process or a check process, and you see that down below. So I want to look at the first one specifically. So in case one, when we had the three coplanar planes, you can see the way I drew the three normals on there, quickly sketch them on, they're all heading in the same direction. This is what we call a dependent system because there's an infinite number of solutions. And here's your check. The normals, okay, are they a multiple of each other? N1 is equal to A, N2, B, N3. And in this case, A and B are elements of real numbers. Okay, so that's your first check. And then your second check, oops, for this to be true, the constants also have to be true with that. So if all three of these are coplanar, they're all in the same plane, or they're all coincident, the normals are multiples of each other, and the constants are multiples of each other. All right? And what I've provided below is what the resulting matrix will look like when you do that. And we talked about solving three equations, three unknowns. You were kind of in your head probably visualizing lines, but it's not lines, it's actually planes, where planes intersect. So because these last two lines turn out to be all zeros, that's your indicator that you're dealing with all three planes being coplanar. So that's what it would look like, or the equivalent. All right. Second case, when you have two planes coplanar and one off, so one that's parallel, this is called an inconsistent system because the three planes do not have anything in common. Okay, all three planes. To find a solution, we're looking for all three planes to share something in common. Over here, they all shared the exact same space, so they're coincident. Here, these two planes have something in common, but we're analyzing three planes, so all three have to have something in common. And they do not, because one's being parallel. So it is an inconsistent system. All the normals, though, are going to be pointing in the same direction again. So your normals are all heading off in the same direction. Oops, so when you do your first check, you're going to find that yes, that's going to be true. The normals are going to be multiples of each other. However, when you look at the constants, one of them's not going to work. Okay, one will work and one won't work. And that is your check or result in this particular system. When you look at the matrix, this is what happens. You get a row of zeros, which tells you that two planes are coplanar or coincident. That third one, we have 0 equals 5 there. Okay? And that basically tells you that 0z has to equal 5, and there's no solution. It's not possible. So that is your third plane that's been lifted off, or is running parallel to the other two. When you see all zeros, that means that it is coincident. All right. And the third scenario, when all three planes are parallel to each other, again, all the normals will be pointing in the same direction, all perpendicular to their plane. They're all pointing in the same direction. So it's inconsistent because the three planes do not share anything in common. The normals will still work for you when you do your test. However, none of the constants will work. And when you go to do the matrix, you'll find that you have not one error, you have two errors. So it tells you that both planes are parallel, so there's no solution. So 0z equals 6 and 0z equals 5. Okay, also no solution. Okay, so that's when all the normals are facing the same direction. So these are all grouped together because they involve parallel planes in some form or other. All right, moving to the next grouping. The next grouping, we're dealing with two parallel planes, and the diagram, again, I'm not the artist in me isn't the best. Two planes that are coincident, they're the same, and one that is not, so it's intersecting. So that third plane is crossing through the two coincident ones. That's a dependent system, and the result will be a line of intersection. Okay. When you go through and do your test, you're going to find that only two normals actually worked out. The third one is not a multiple of it. So right away you know that you're not dealing with three parallel planes. And this is what's going to result in your matrix. You're going to get one row of zeros. And again, when you get a full row of zeros, that means you have coincident planes. Coincident planes. And then you're able to get a solution for the third row. For this one, sometimes people confuse this and say there is a solution, but there's not, because the three planes don't share one thing in common. Yes, there are lines of intersection, but those lines of intersection are in two different locations. So this is an inconsistent system. Okay, so an inconsistent system means there's no solution. They do not share anything. And the same thing again, you will get normal 1 being a multiple of one of the other normals. But what will happen here is very, very similar to the three parallel planes. You'll see that we still ended up with no solution for the second and third. So this doesn't necessarily tell you whether you have three parallel planes, and that's why we have to do this previous check before we go ahead and solve, so we know what we're dealing with. Okay, so you know whether you're dealing with three parallel planes. I'm going to explain that when I go through and do an example. The last one I want to talk about here, on this slide anyway, it's when we have three planes and they form a triangle. So if you have three pens or pencils in front of you, just arrange them so they form a triangle. There's three lines of intersection. Again, it has to be a shared common intersection. So it's an inconsistent system, no solution, and in this case, none of the normals are a multiple of each other. Okay, and the resulting matrix looks like this. And again, when you go to describe, when I ask what type of system are you dealing with, just going through and doing the matrix is not going to help you, because if you look at 5 and 6 here, the matrices look identical to each other. So you aren't going to be able to tell me that with this matrix here, you're making a guess. Is it this one? Or is it this one? So that's why these checks that I have written out here are very, very important. And people ask, do I have to write them all down on my cheat sheet or memorize them? You got to use common sense. You can put them on your cheat sheet. I'm not going to stop you, but common sense will tell you if you have two normals heading in the same direction, you've got two parallel planes at least. And if they are not equal, the multiples of the constant, then they're parallel and not coincidence. So it's not impossible to go through this without putting any of it on your cheat sheet. Final two systems that we're looking at. If you arrange your pens or pencils in front of you such that they overlap at the same point, so they're on your desk, but they're overlapping at the same point, so the line of intersection would be going in and out of the board here, or in and out of your desk when you're looking at your pencils. So it's a dependent system. You'd end up with a line as your solution, and it occurs when all three normals, okay, are not in the same direction. And this is what the resulting matrix would look like. You get a row of zeros again, but you have to do the check because you know when you check your constants for situation number 7, you'll know that you're not dealing with parallel planes. Okay? And finally, when you stack up pieces of paper, and you would have done this in your investigation, there is possible to arrange the planes such that if you put them in the XY plane, the XZ plane, the YZ plane, they meet at a point. So the origin, for example, 3 planes would meet at the origin. This is the only situation where we have an independent system. We have one solution. And in that case, when you do the normal check, again, none of the normals will be equal to each other. And your matrix will actually spit out a final answer. So it'll be the only matrix where it's in that format that we were looking for when we went through and did matrices. Okay? So that's a quick, those are the 7 scenarios, or I guess classifications here. So we had the first 3 when you're dealing with parallel planes. You had the second 3 here, and then the final 2 on the last page here. So we have a total of 8 that you're responsible for and being able to identify the difference between. And on a test, you're going to be given either a matrix form, and I'm going to ask you what are the possible outcomes for these planes or their arrangements, or I may just give you some information and then you tell me the conclusions from that. All right, so we'll do some examples in the next lesson.